Okay, hi everyone. This is the recording for the handout on volcanic hazards. This is where we'll stop for your end of year exams. Okay, so before we go on, right, I want you to recap very quickly the two different kind of volcanoes that we have learned, which is your strato and shield volcano. Okay, and at the same time, I want you to explain at each type of blade boundary what happened that led to different kinds of magma, which then led to the different kinds of volcanoes and the type of eruption. Okay, pause the video and do it now. Once you are done, please unpause the video. Okay. Alright, I think you're done already. Okay, so let's walk through this to explain what are the different kind of volcanoes so we understand the different kind of volcanic hazards. Okay, so let's start at divergent plate boundary. So at divergent plate boundary, this is an example for divergent plate boundary. Okay, so you have the oceanic crust, the oceanic plate, two oceanic plate moving apart from each other. Then there's the external sphere here. Okay, so what happens is how does it form magma? So as they move apart from each other, the external sphere, the rocks are exposed to lesser pressure. Okay, so it was the high pressure that pushed all the molecules to make it behave like a semi-solid. So now with less pressure, the rocks are more ready to melt, okay? And then it forms magma as a result, all right? Okay, so for this case, almost all the rocks melt, which as a result, they form low silica magma, all right? So what do we have over here? Because of, let me zoom in further. Okay, so because of it lowers the pressure at the asthenosphere when the plate moves apart. Okay, it results in the rocks in the asthenosphere melting, forming low silica magma. Okay, so since low silica magma is less viscous means whether how easy is it to flow. So viscous means hard to flow, sorry. Okay, so if it's less viscous means that it is easier to flow. I'm not sure if you still remember where we did the honey and the peanut butter experiment. Okay, so honey is the less viscous one, is easier to flow. So when it's easier to flow, air inside the magma is easier to escape. So as a result, there's less air being trapped. And also because it's easier to flow, it's less likely to get stuck in the conduit of the volcano, the part where the magma flows onto the surface. Okay, where the magma flows from the chamber onto the surface of the earth. Okay, so it's more likely to flow very smoothly rather than solidify and get stuck. Okay, so when if it's less likely to get stuck, then when more magma comes into the trying to erupt, there's less pressure as a result. Okay, so overall there's less pressure on the volcano. Okay, so as a result, the eruption is likely to be more effusive, forming a shield volcano. Okay, why is it called shield volcano? Because it's very rounded, it's very flat, like a shield that is placed on the ground. Okay, so in this case where there's a divergent plate boundary, so when faults occur, right, usually there's faults because of all the weakening of the crust, the magma can actually flow up the fault and then erupts as your first layer of your volcano. Okay, and then it hardens into the first layer of the volcanic cone, and then with more eruption, then it will form multiple layers and form a taller volcanic cone. Okay, so let's look at what happens at convergent plate boundary. Here's a convergent plate boundary. This time we're looking at I mean, it happens to any convergent plate boundary. It can be oceanic, convergent, oceanic. Okay, but this doesn't happen at continental, and we will look at it why. Okay, so when there's a oceanic plate boundary, oceanic plate with a continental plate moving towards each other. Okay, so the oceanic plate being the denser one will definitely subduct. Okay, let me repeat that again. So it will, as you push further, the continental plate is being less dense, will float on the asthenosphere, but the oceanic plate being more dense will be pushed beneath the continental plate. Okay, so it subducts. And when it subducts, right, the asthenosphere will squeeze any sediments that the ocean floor has. Okay, the water, because it's ocean floor, the sediments is filled with water. So once it's pushed into the asthenosphere, the heat and the pressure will force the water out into the asthenosphere. Okay, now what happens when this water is in the asthenosphere? It will cause the rocks in the asthenosphere to lower its melting point, but only for the high silica rocks. Okay, so the low silica rocks, nothing happened to them. but the high silica rocks, the melting point will lower. Okay, so as a result, right, it triggers only the high silica rocks to melt, forming high silica magma. Okay, so when there's faults at the crust, which is very common because a lot of compressional force will weaken the continental crust, okay, the magma has a chance to travel up the faults, okay, and then of course erupt to form your first layer of your volcano. Okay, so they harden and it forms the first layer of the cone. Alright, so let's go through the process here. So when plates move towards each other, the oceanic plate will subduct, okay, and then the high pressure on the subducted part will force the water out from the sediments into the asthenosphere. So this causes the lowering the melting points of some rocks, and the sum refers to the high silica rocks, which as a result forms high silica magma. Okay, so for subduction's case, only the high silica rocks gets to melt, but in the divergence case, all the rocks gets to melt. So which is why when you combine them at divergent plate boundary, since all the rocks get to melt if the magma is low silica, but at the convergent plate boundary, because only the high silica rocks get to melt, it forms high silica magma as a result. Okay, so since high silica magma is more viscous, okay, like your peanut butter, it's very hard to flow. It takes a long time to flow, and make it harder for the trapped air to escape. So you trap more air. Okay, and it's more likely that as it's traveling up the conduit, it will solidify because it's so hard to travel. It's likely to solidify even before it gets erupted. So when more magma is rising up into the volcano, it creates more and more pressure. Okay, so the air is adding more pressure. The solidification of the magma inside the conduit adds more pressure. It causes the pressure in the volcano to be very high. And as a result, when they cannot take the pressure, it's likely to form a very eruptive, very explosive eruption. Okay, and this is at the stratovolcano. Okay, so today we're going to learn with these two separate eruption types, what are the opportunities or what are the potential for it to cause a lot of death, injuries, and damage. Okay, what is the danger that it poses to people and nature? So we're looking at things that pose danger, can cause a lot of death, injuries, and damage. Not that it will, but it can. Okay, so this is why we call it hazards. Okay, so what are different hazards that happens at volcanoes when they erupt, and how is it different at different places? Okay, now over here, so you need to know what are the different hazard types, okay, that are caused by volcanic eruption, and explain how it can impact nature and also humans. Okay, now in your textbook and syllabus, it says impact of tectonic hazards on natural and human systems. Okay, systems means when it impact human, it impact nature, what else does it impact? But for the scope of our examination, right, we're just going to keep it to direct impact on nature and human. You're not required to go on to explain further impacts because that requires a certain level of understanding of human and nature systems. Okay, so in explaining how it impacts nature and humans, this should be good enough to help us show how well you understand the characteristics of these hazards. Okay, so now you're done with page 1. Now I'm going to leave these two blank. You're supposed to fill out your own at the end of the recording and tell me what are the main hazards at shield volcano eruption and at the eruptions of stratovolcano. Okay, so let's make ourselves familiar with the different hazard types. Let's move on to page 2. What are the main hazards from a volcanic eruption? Using these photographs, can I get to identify what are the possible hazards that you know? Okay, so you already have these hazards mentioned here. Okay, so can you put them into this picture? Which is which hazard? Can you make a guess? Okay, pause the video and make a guess. And then once you're done guessing, you can unpause the video. Okay? Alright, have you done guessing? Alright, so let's give it a try. Now, all these things that's flowing, all the melted rocks that's flowing is your lava. Okay, so magma and lava is the same thing. They are both melted rocks. It is just that when magma is under the surface, it's called magma. Alright, and when these melted rocks erupt onto the Earth's surface, it's called lava. Okay, just like how at home your parents may call you with a certain name, but in school you're called your other name. Okay, so same person, just that in different contexts you are named differently. Okay, So this is on the Earth's surface, we call them lava. And one the hazard is that the lava will flow. Okay, it can flow a long distance, especially at true volcano, where the lava is less viscous. Okay, now this is not so obvious. You can see a hole here on the slope, and you can see a lot of white color debris. Okay, so what happened was that this was a normal slope, like this green color patch over here, and when the slope fails, the slope can no longer hold its shape. This whole part collapsed down. So you see a scar where the debris was at. It collapsed and flowed down the slope. So the debris will flow down and bury the area. Okay, sometimes what happens is that at volcanoes, the eruption can be so explosive, it destabilizes the slope and it actually collapses. Okay, so all this collapsing of slope, we call them landslides, but since it happens at volcanoes, we call it volcanic landslides. Okay, now this big thing over here is a rock. Now it may look like just no big deal, but these are what we call volcanic bombs. Okay, so volcanic bombs are anything that can be as small as a stone to be as big as your classroom. Okay, so what happens is that there are semi-molten lava that was thrown out of the volcano due to the explosive eruption, and it can fall over a few kilometers away from the volcano. Okay, and it can just smash into villages, crush people, smash their properties and stuff like that. Okay. The next one, this fine thing is also erupted by volcanoes. Usually it's floating in the air before it settles down. It's what we call ash. Okay, volcanic ash. And when it falls down from the sky, it can call volcanic ash fall. Okay, now a few things to take note. Okay, so let me just split the window quickly. Okay, so you looked at volcanic bombs and lava flow. Okay, then what the hell is tephra? Okay, teacher, what's tephra? This difficult word. Now, so what is tephra? Tephra basically is anything solid that is thrown out from the volcano. Okay, so when the volcano erupts, anything solid is called tephra. So these two things, volcanic bombs and ash flow, volcanic bombs and volcanic ash, this is what we call tephra. Okay, now just take note again, volcanic bombs can be as huge as a car or even bigger than a room, or it can be as small as a pebble, okay, or a small piece of rock. Okay, or it can even, and tephra can be as small as your fine ash that's flowing in the sky. All right, now the other two hazards that we're looking at is volcanic, the other two hazards that we're looking at is pyroclastic flow. Okay, pyroclastic flow. So what's pyroclastic flow? Pyroclastic flow is a hot cloud of ash and volcanic ash and with rocks inside rolling. Okay, they flow at fast speeds up to even 200 kilometers per hour. All right, your car on the expressway is only about 90 to 100 kilometers per hour. Imagine doubling that speed. Okay, so volcanic ash cloud with some of the other tephra can form pyroclastic flow if we choose to rush down the slope of the volcanoes. Okay, and these are not cold, these are hot ashes. They can burn a few hundred degrees Celsius. Okay, they have done archaeological studies of places that were caught by pyroclastic flow. What happens is that they found that these people, right, what's left is only the skeleton because the flesh was boiled and burned off immediately. The brains show evidence of being boiled off and burned off immediately when the pyroclastic flow came in. Okay, so this is one of the more dangerous hazards. Okay, now this one, you see the houses being buried. Okay, this is not buried by the landslide. Rather, when there's ash, okay, when the ash mixes with water, all right, so it could be ash that's already fallen onto the ground, okay, or it could be ash in the sky and then it mixes with rain, or it could be ash on the ground, mixes with rain, mixes with river. Okay, so they can form a huge volume of mud flow. We call it lahar. Okay, lahar is actually an Indonesian word for mud flow, but they have used it officially on this already. Okay, so lahar, a huge volume of mud formed by volcanic eruption, and when they come in, they can come in like about the speed of a car, 100 kilometers per hour, and a huge volume that can bury the whole area. Okay, so let me show you some pictures of these and videos of these hazards that we're talking about. Okay, the last hazard is volcanic gas. Can't really show you with picture because gases are invisible. Okay, so there's no picture for it. Alright, now before we go on into the videos, can I give you some time to label some of these hazards that you already see, okay, that you already know onto here. Okay, can I pause the video? And then once you're done, you unpause it to complete the once you've completed the diagram, then you unpause the video. Okay, are you done? All right, so let's label them. So they've already labeled lava flow for you. Okay, so what's these huge things that's flying above? All right, this huge thing that's flying above, those that is visible to you like opaque stuff, right? That's basically your ash, volcanic ash. Okay, let me just change the color so that it's clearer to you. Okay, now of course when it falls down, there will be your ash fall. All right, there's also a volcanic gas that you can't really see. So fine, if you didn't label it, it's not visible. Okay, and then we have these things that is bouncing off. This solid, what's this solid? These are actually your tephra. Okay, so specifically, but tephra can also mean volcanic ash. So specifically, your volcanic bombs. Oops, where did the words go? Okay, all right. Now, you have this thing that's flowing down like a thick mud. So this is basically your lahar. Okay, and this part you have signs of the slope collapsing and then flowing down as debris. So this is your volcanic landslide. Okay, lastly you have this huge cloud of ash flowing downhill. This will be your pyroclastic flow. Okay, difficult word, let's break it down. All right, pyro in Latin means fire. Okay, so you might have seen comic book heroes named Pyro or something because they have fire related powers. Yes, that's why they're called pyro. Pyro means fire. Okay, clastic suggests that it's like plastic. Okay, so like something that is moldable, very fast flowing. Okay, so fire cloud that is very moldable and fast flowing, they form your pyroclastic flow. Okay, so let's see pictures of it and videos of it, shall we? All right, so they can better understand and visualize it. This is your Okay, so this is some of the major volcanic eruptions in the world. This is Krakatoa actually. So Krakatoa is actually in Indonesia, between Padang and Java Island. Okay, so this is considered to be one of the loudest eruption in the world because when it erupted, it created such a loud sound that it can be heard hundreds of kilometers away. Okay, where exactly is Krakatoa? Let me show you a picture, a recording of it. So this is Singapore. All right. So if you were to zoom out of Singapore, okay, so you have Malaysia over here, and you have Indonesia, Padang, and Java Island. So Krakatoa is actually found somewhere over here. Let's zoom in inside here. Okay, so right now you see Krakatoa is not what it was. Okay, in fact nowadays they call it Anak Krakatoa, which is the son or child of Krakatoa. Alright, what's it called that way? The original one was much bigger. It was actually, this whole island was Krakatoa. So what happened to it? Okay, so in 1883 there was a major eruption. It was so explosive that so much materials and ash was sent into the sky, as you can see over here. Okay, so you can see it was a complete beautiful cone, right? But it was so violent, the top part was blown away by the eruption, and that's why you only see the bottom half here. Okay, so this explosion sent so much ash, so much energy, it created a major tsunami. It was so loud that actually in Straits Times in the 1880s, they actually recorded people hearing it from Mount Faber. Okay, and it was as loud as, you know, the kind of military artillery that was used to shoot long distances, right? It was as loud as those bombs. Okay, so it was so far away and yet so loud. All right, so the whole island was this, the whole volcano was this size, but it was so explosive, it blown off so many parts of it. So Anak Krakatoa didn't exist actually, okay? So the whole part was blown off. And then after multiple years of eruption, the lava solidified and formed a new cone called Anak Krakatoa. Anak means sound, child of, okay, child of Krakatoa. All right. So this was actually a very major thing. The ash, there was so much ash, it was sent up to the atmosphere. The ashes actually circulated around the atmosphere for multiple years. Because there's so much ash in the sky, right? It made the moon look blue at night. So which is why you had the saying once in a blue moon, okay, which is a rare event. All right. In the daytime, the sky was just orangey, and instead of blue and yellow, it became blue and yellowish. It was just orangey throughout because of the ashes. Okay. Apparently, this was what inspired the artist Edward Munch. I can't pronounce his name. The artist who drew the famous painting called The Screen, right? Why did he drew such orangey skies? Because that was what he saw due to the eruption of Krakatoa. Okay, so this famous painting, you might have seen it. All right, so now you know that the orangey skies is because of the eruption of Krakatoa and the ash that was circulating around the Earth's atmosphere at that time. Okay, this is not me and your marking. This is just a famous painting. Okay, Krakatoa somehow is very explosive. Okay, so this Anak Krakatoa, it became a smaller volcano. So last time it was much taller than this. With over the past 100 years, it has multiple eruptions. So layers and layers of solidified lava, it becomes a cone again above sea level. And then just 6 years ago, another explosive eruption. It blew off the whole cone, and this was what's left behind. Okay. Yeah, so you can see the difference. So this is what explosive eruption can do, and it blows off so much of the rocks that became ash and float around the atmosphere once again. Okay, let's take a look at lava flow. So this is lava flow at Kailua volcano in Hawaii. Okay, so you can see that it flows. Okay, so you can see that it's flowing. All right, flowing very quickly. Okay, so this is a low viscosity magma lava, which is low in silica, like your honey. Okay, so they can flow. You can see that it flow very fast and flow very far. So what happens when it can? How does it cause? Or why is it a hazard? Well, as it flows across the island, okay, you can see that it actually flows into houses. Okay, and it burns property and burns houses as a result. Okay, of course, it flew far enough to went into the ocean actually. Okay, so it's not like, oh, okay, after the disaster I can just dig out the lava, right? Okay, these are super hot, and when they solidify, they become rocks. Okay, so how are you going to hack away so much rocks that covered and solidify your property? It's not possible. Okay, here's an example. All right. So this one is a bit less viscous, more viscous, because the rocks, as you can see, the lava, as you can see, is quite solidified already. All right, but it's still moving at quite a rather fast pace. You can see it moving into the car. Okay, I think thankfully the person has already escaped. All right. Yep. So there goes the person's car. Okay, burned and buried forever in the rocks. Okay, this is the gate of someone's property. All right, so the massiveness of the lava, you see, it's very hard to build barriers because it's just so hot and so massive. Okay, so you can see it rushing through people's gates. Okay, and the gate was just melted inside, so now it is burning and burying the properties of this person. Okay, so you can see it burning from the heat. Okay, so a few thousand degrees Celsius, that's why. All right. So this is what we have for lava. Okay, so let's move on to the next one. The next one is gas. Okay, so what happened in the 1980s, that there was this village in Africa, right? One fine day, when people visited, they realized that all the livestock, all the cows, all the goats that they kept for food, and a lot of the villagers inside died. Okay, they were lying down as if they just never woke up from the sleep. Okay, so what happened was that they discovered that the nearby Lake Nyos is actually part of a volcano. So this is actually a volcano crater, all right? And the volcano has been erupting gases, a lot of carbon dioxide. Okay, so one fine night, the carbon dioxide was released and it rolled down the slope and went into the villages. Okay, so since it was all carbon dioxide, it pushed out all the air, pushed out all the oxygen, and these people who were sleeping, the animals who were sleeping, didn't realize that their gas has been replaced with just carbon dioxide, and then in their sleep they suffocated to death. Okay, so this is how deadly volcanic gas can be. Okay, we talked about lava flow already. I'll skip this. This is ash fall from Pinatubo. So 1991, Mount Pinatubo in Philippines had a very major eruption. Okay, so after they erupted and the ash was falling, what does it look like? Let's take a look. Okay. Okay, so this is the ash falling. All right, so it's not like, oh, just misty sky. Okay, you can see particles falling down. Okay, so can you imagine living in this condition? And then you're breathing in all these ashes, what it could happen to you. Okay, so you can see this person's face covered with ash. Even though it's far away from the volcano, like 20 kilometers away, the ash fall does still affect them. Okay, and Pinatubo, the winds were in the right direction. So this was the ash after the volcano. So you can see that it covers all the crops, it covers all the plants, okay, and the trees. It doesn't really block photosynthesis that much. It doesn't really like suffocate them, but rather if there's enough ashes on the trees, right, the additional weight of the ash can actually cause the branches to break. Okay, and that year, because the wind was in the right direction, it actually blew all over to Singapore, and Singapore actually felt, hey, how come there's more ashes? All right, like this guy over here, he found that there were ashes on his car. Okay, so it wasn't that much of a nuisance to us, but people living at near the area where the ash was falling so badly, like what you saw just now, right? Okay, can you imagine trying to breathe in this condition? Okay, trying to breathe in this condition, what can it do to your health? Okay, and imagine all the houses with all the ashes. What can happen to the houses with all this added weight? Okay, this is lava bombs, example lava bomb. So this was fresh out of the volcano, it was still solidifying. All right, you can see that it can be very big, it can crush people. These are pyroclastic flow from Mt Merapi. 2018, Merapi in Indonesia erupted, so it created a lot of pyroclastic flow. Let's take a look at what does it look like. Okay, so you can see this cloud rushing down the slope. Do you see that? This cloud rushing down the slope. Okay, here's another view. You see it rushing towards you. All right, very fast, right? And these are hot, 180 over degrees Celsius, even thousands of degrees Celsius hot. Okay, so you see another ash cloud rushing down the slope. Here's another pyroclastic flow. Or even if you don't get burned to death, don't forget there's rolling boulders and rocks inside, so you might get crushed to death also. Okay, so here's another view. You see this whole ash cloud rushing down the slope this way towards the left. Okay, here's another one rushing down the slope. You see that? Okay, you see that it's pushing rocks flying around. Okay, so if you are caught in it, you can't really run away from it. It's too fast already. Okay, here's another one rushing down the slope. Okay, there's a more zoom in version. You see this rushing down the slope. So this is how fast pyroclastic flow can be. Okay, so you can imagine what happens when it goes on to human property, villages, or even forests. Okay, this is a classic picture from Pinatubo, 1991. This is a bunch of scientists observing actually. So when the pyroclastic flow rushed down, they were running away, trying to run away from it. Thankfully, they were fast enough because the pyroclastic flow here is at its end of its journey. So it has slowed down significantly already. Okay, if they were at the slope of the volcano, they would not be able to outrun this. All right. Here's a version of this lahar. So lahar, remember, is a mud flow when the ashes mix with the water. So this is your lahar. Remember this lahar? Okay, this is your lahar. So when ashes mix with water, it can form fast flowing mud at a huge volume. So this is not a river. This is actually lahar flowing through. okay, from Mount Sumeru eruption in 2023. Let's take a look. Okay, you don't really hear the sound because I didn't share the sound, but you can see how fast they flow, how destructive it can be. Okay, look at how fast it flows. Alright, yes, it's mud, it's thick, it's like cement, but because of the huge volume, it can flow very fast. Okay, this is from the 2018 eruption in Mt Merapi. Okay, so you can see the volume, the speed of it. This is mud, this is just sticky mud, but yet because it's so much volume, it can flow so quickly and flood the whole place and bury the whole place actually. Okay, this is from Pinatubo. I keep mentioning a few classic cases so that you don't have so many case studies to remember. Alright, so Mount Pinatubo had erupted so much ash, and then it coincided with typhoon some more. Okay, so the ash mixed with heavy rain forms a lot of lahar. Okay, so you can see the lahar burying the whole village over here. Right, so what's left is you only see the roofs. Okay, you can see this, for example, this building at the village, alright, is 2-story tall. What's left is just the top of the roof. Okay, the lahar has buried the whole thing, the whole area. This is how big the volume it is. Alright, and it's not something that I can really scoop out because lahar, it can also solidify over time. Okay, so these places might be buried for good, and you may not have the resources and manpower to dig out so much of the ash. Okay, last one I'm going to show you is about volcanic landslides. This is Mount St. Helens. Mount St. Helens in America is a very famous eruption. Okay, so this is like a time lapse because at the time they don't really have the technology to film for so long period of time. So what they do is that they take multiple photos at different minutes. Okay, so they stitch together to become a video. You can see what happened to this slope. All right, so as the volcano is about to erupt, it makes the slope less. Okay, let me just skip the part. Okay, so what happens is that when the volcano is about to erupt, it made this place, there's so much pressure that it caused the whole slope to fail. The whole slope couldn't support itself and it slid down. So let's see it sliding down. Okay, you can see the whole slope collapsing, sliding down. You see that it forms the scar that I was telling you. And then the debris would then go over to bury the rest of the forest. Okay, let's take a look again. So you can see the whole slope going down. So this is not like additional pyroclastic flow or additional mud flow. This is the cone itself collapsing down. Okay, so this is what I mean by volcanic landslides. So before, this is what it looks like. After, you can see the whole area, the whole slope has collapsed and flowed down and filled up the valley over here. Okay, so this is what I mean by volcanic landslides. Alright, so now that you know these are the different effects of the characteristics of the different hazards, okay, can I give you a few minutes to tell me how do you think it affects nature? How do you think it affects humans? Okay, now please be specific where it happens, be clear of the scale. Is it around the volcano? Is it further away from volcano? Is it a global thing? You must be very clear of the scale because as geographers you must be very clear. Okay, and of course you must also think of in terms of time scale. Okay, is it a short-term or long-term thing? So for example, volcanic gas, okay, I talked to you about how you can have a huge amount of carbon dioxide that concentrates at the low-lying area near the volcano. So I'm very clear that it's near the foot of the volcano. Okay, and then when there's a lot of carbon dioxide, you may push out the air, leading to insufficient oxygen, causing the people in the area to die. Okay, so the animals in the area and the humans in the area, which is the area near the foot of the volcano. Okay, I also talked about acid rain. So sulfuric dioxide is also released by volcanic gas. It can form a very weak acid with the air, okay, and the water particles. Now remember, it's very weak acid. Okay, please remember it's weak acid. So it's not a case of, oh, it rained one time, then suddenly it caused everything to dissolve like a pH 1 kind of acid. Okay, it's very weak. Okay, so it takes a long time for it to cause damage. So it can slowly damage the vegetation near the volcano. Okay, and the areas near the volcano, it can slowly corrode buildings and infrastructure. Then when you're exposed to too much acid rain, you can suffer from irritation. Remember, it's over time, not immediate. It's not like after it rains one time, the building will collapse. Okay, so can you do the same for lava flow, tephra, and pyroclastic flow, lahar, and volcanic landslides? Okay, pause the video and try to complete it. And once you're done, you can unpause the video. Okay, are you done? Let's take a look. So lava flow, very fast. Okay, so what does it do to, let me just switch this to the right place. Okay, let me just do this. Okay, so let me keep the header here so it's always there for you. Okay, so lava flow, what can it do? As you can see, it can actually it can burn and bury these areas near the volcano. Okay, and for some cases, it can travel far. Okay, and in some cases, can travel areas far away from the volcano, up to hundreds. Okay, as you can see, because it can cover for a huge area before it solidifies. All right, and of course, when it bury the area, it bury the areas permanently, right? Because the rocks, the lava will solidify, so it's going to harden. Okay, so it's going to harden. There's no way you can easily remove the rocks and recover the nature that's there. Okay, so likewise for humans, you burn and bury areas. So what happened is actually permanent loss of land. And properties. Okay, how about, that's how you are thinking, how about burning people? Okay, so as you can see, even the most fluid one, it takes a while so people can actually escape, but in rare cases, okay, so people may be trapped and burned to death. Okay, now for tephra, as you can see, it can fly, but it's only a few hundred meters from the vent. So what can it do? It can crush forests and rivers, okay, near the volcano. And likewise for humans, it can crush humans and properties near the volcano, because it can't really travel very far. Okay, so it's very limited area that it can hit. As for ash, as you can see, it can go to a very far distance. Okay, so it can actually cover huge areas of vegetation. Okay, even far away from the volcano. Okay, so likewise for here, it can fall onto properties, which can, if too much, the property may collapse from the weight of the ash. Okay, so humans can imagine bringing all the ash, what will happen. So humans can get respiratory disease. I forgot to specify where. Okay, but for ash, it's only near the volcano. Oh, okay, sure. Okay. Why do I have two separate box boxes. Actually, there's no need for to separate boxes. I'm so sorry. Okay, I know why already. Sorry, this one is supposed to be here. Supposed to be here. Okay, as for the one that goes into atmosphere, what happens is that it can actually lower temperature in the atmosphere for a few years. Because why? The ash can reflect sunlight away. Then it can actually lead to a lower temperature for a few years. So how does it affect nature? It can disrupt okay, likewise for humans, what happens is that it can actually disrupt your crop growth. Okay, so what happened when Krakatoa erupted, right? So for a few years when the ash was circulating in the atmosphere, the temperature lowered so much that the summer was too cold, so the crops couldn't really grow well during that period of time. Okay, in Europe and North America. Okay. Now let's move on. Pyroclastic flow, what can it do? As you can see, it doesn't really go beyond the near the volcano, right? Okay, so what it can do, it can actually crush and burn forests near the volcanoes, especially the base. So what happens, it actually destroys habitats, right? Okay, as for humans, well, if you are living near there, you can also get crushed and burn villages near the volcano. Okay, lahar, it can travel for a much further distance, so it can bury large areas of forests and habitats near the volcanoes. So you have a loss of habitats. Okay, and likewise for here. Right, as you can see, it's very fast, so people who are caught in it cannot escape from it. Okay, likewise for volcanic landslide. Okay, but it's usually at the base of the volcano lah. Okay, so we'll stop here. After exams, then we'll move on to talk about how it affects systems. Okay, so let's do a quick recap of some of the hazards, and I'll show you actual pictures from Merapi. Okay, so these are pictures shared with my colleagues and I when we visited Merapi, and we brought students to visit Merapi and one of the schools near it. Okay, so the teachers shared the photos they've taken after the 2010 eruption. Okay, so you can see the Merapi is here, and you can see the amount of ash. You can see this thick layer of ash, and they cleared the middle of it. Okay, left behind by the volcanoes, and of course the smaller tephra, smaller rocks. Okay, this whole area, the trees were burned and killed by falling ashes. Okay, so you can see the trees here. You don't see many branches. Why? Because there was so much ash, and then the branches actually broke off and collapsed. Okay, here you can see all the ash covering the cemetery, the grave of the cemetery. Some warning sign about lahar. Lahar is actually an Indonesian word. Okay, but the world has incorporated it to refer to this mud flow. Okay, I think this is from the school that we visited. They actually rebuilt the school, so you can see this whole one story of the lahar actually covered almost the whole first story of the school building. Okay, this is a village that was hit by tephra. A lot of ash. You can see a lot of ash. I think they dig up a pathway. You can see this huge volcanic bomb that fell in the village. All right. See, there's so much ash. This was a path of pyroclastic flow. You can see all the trees being burnt, and then by the pyroclastic flow. So you can see that it probably came down from the Merapi here, down this area. So the pyroclastic flow didn't hit this tree, so it was spared. But you can see so much more ash, and these trees are all burnt. In some more severe cases, the trees will actually be crushed and will actually all collapse. Okay, here's a huge volcanic bomb left behind. You can see how big it is. Okay, so this was a river that was clear, but lahar actually flew through it. It wasn't so bad, so it was only some parts of the lahar here. It narrowed down the river. You can see the lahar here, the lahar here. Okay, This is the farms nearest to the volcano. You can see the ash. It's very blurry, but I can see all the crops here buried by the ash. Okay, this is a path. This is somewhere that's in the path of a pyroclastic flow. So you can see the trees here all pushed down to a certain direction towards you, right? So because Merapi behind, the pyroclastic now flew down, rushed down, and pushed all the trees down here. Okay, so it was so hot, it instantaneously burned and rust this motorcycle that was left behind. Okay, this was what's left of their home. You can see this car that was left behind, the pyroclastic flow burned and rusted it very quickly. Okay, so these are pictures that you can see. All right, now before we go on to the questions, I want you to try and pause and think of this question. Let's go into page 1. So what do you think are the main volcanic hazards for these two types of volcano? Now you learn that shield volcano is very effusive. You learn that stratovolcano is very explosive. Okay, as a result, what kind of hazards will feature more in which type of volcano? Okay, so you learn the different types of hazards, right? All these different types of hazards. Which one will be found more in which volcano? All right, please pause the video and fill up. And then once you are done, you can unpause the video. Okay, are you done? Right, let's give it a try. Lava flow, as you can see, because at shield volcano, it is very, it's low viscosity, can flow very far. So this is one of the main volcanic hazards there. Okay, less so as strato because it's very hard to flow. Most of the time, the lava won't go beyond the slopes of the volcano. Okay, ashfall, you can see that it's happening more at stratovolcano because it's a lot more explosive. So it creates a lot more ash. Okay, likewise for tephra as well, and volcanic bombs. Okay, gas you can see in both actually. No, actually not really see, but yeah, it happens in both. Okay, now pyroclastic flow, you need a lot of ash for it to happen. Okay, so actually it happens more at the stratovolcano. All right, and lahar likewise you need a lot of ashfall to mix with water. So of course it happens more at stratovolcano. Okay, and lastly, you need a lot of explosive eruption to destabilize the slope. So volcanic landslide, it can happen in issue, but it happens more at stratovolcano. Okay, so this is what are the hazards we see at the different types of volcanic eruption. All right, now let's take a look. Let's try some questions. Okay, let's look at the last page, second last page. Can I get you to try this? What hazard do you think it is? And then tell me what's the impact on. Can you change the question? Nature. Okay, so this was the eruption of Mount St. Helens. What happened to nature? Can you identify the hazard and explain? Okay, pause the video and try the question. Okay, have you tried this question already? All right, let's give it a try. Now you're supposed to explain the impact of the eruption on nature. I told you to change the question from ecosystems to nature near Mount St. Helens. So you have this picture of the eruption of a forest near Mount St. Helens. Look at what happened to it. Okay, so you see a lot of the tree has collapsed. All right, and the branches seems to be gone. You don't see thick layer of ashes, do you? Or you see some ashes? You don't see any debris burying the forest, right? Okay, so what are the possible hazards that could be the one that resulted in this? Okay, so let's take a look at what we have learned. Eruption cloud falling ashfall. Ashfall would be a thin layer, right? And some branches will break off. It will not be like the whole tree collapse. So it's not likely to be ashfall. Okay, if it's lava flow, we have seen like solidified rock bearing the area, right? So it's not lava. Lahar will mean that it would have buried the whole layer with mud, right? So this is not lahar. If it's volcanic bombs and tephra, you have seen the volcanic bombs, but you don't see any of it, and it doesn't cover such a large area. So it's not volcanic bombs, not ash. Gases only suffocate the animals, not the tree, so it doesn't apply. If it's volcanic landslide, right, then it would have again be debris bearing the area. We don't see any debris bearing, so no, it's not volcanic landslide. What's left is pyroclastic flow. Okay, does it suit the condition? The ashes, yes, pyroclastic flow has a lot of ash. The trees looks burnt, and pyroclastic flow, if fast enough and with enough, it can actually push everything down the collapse to one side. So this looks like effect of pyroclastic flow. Okay, so let's answer them. What is the impact of nature on Summarise hazard? So what is the hazard involved first? Okay, so pyroclastic flow. So what's the hazard involved? And how does it do it? So pyroclastic flow from Mount St. Helens, okay, could have rushed down the slope and onto the forest near the volcano. Okay, so what did it do? What did it do? So the pyroclastic flow burnt through the forest, okay, causing the trees to die off, okay, and it also pushed the trees to collapse, okay, causing the whole area of forest to be destroyed. Okay, again, I told you, I don't want to see the word affect. Affect is very fake. So tell me exactly how it's affected. Okay, so how does it affect nature? Okay, so you could tell me things like, for example, so explain means tell me the steps, right? So then what does it lead to? Okay, so you could tell me that the whole forest is permanently destroyed, so it's hard to regrow. You could tell me that habitats are destroyed, animals who live in it okay, so each of these points is really worth 1 mark. Okay, so I've given you 4 possible marks of possibilities here. Of course, there could be other things, like some of you might say that for example, animals are killed in the process, also can. Okay, but basically how it affects nature, some simple effects is good enough. Okay, of course you must be clear of the location. So whole forest near the volcano or near Mount St. Helens, okay, or near Mount St. Helens in this forest. Okay, so any of this, preferably one step lead to the other step because it's explained out. So 1 mark, 2nd mark, 1 mark, 2nd mark. Okay, so how you explain? First, you tell me what's the hazard involved, what does it lead to, and then how does this then affect nature? Okay, so maybe this is actually more for the next one. All right, yeah, this will be better. Okay, so 4 marks is here. All right. Okay, so can you get you to try the next question on your own and we go through in class? Okay, so this is a river that is filled with lahar, so we made it clear to you what's the hazard after the 2023 eruption of Mt Merapi. Okay, so using figure 2.1, describe the characteristics of lahar. What do you see? What is it like in terms of volume, in terms of consistency, and things like this? Okay, if you're just going to copy and paste from the notes, for example, this is what some of you might do. So some of you just look at lahar, oh, I'm just going to copy all this. Okay, then my question to you is, first things first, where do you see the mixing? Where is the ash cloud to mix? Is it shown here? It's not. So to anyhow put it in. Okay, or you just tell me, oh, it mixed with rain and water body. Where's the evidence that it's mixed? Don't have. So don't come and tell me that. Okay, next thing, some of you may just copy, it can flow more than 200 kilometers. Where is the evidence that it's flowing more than 200 kilometers? If it's flowing very fast, this man wouldn't be crossing, this bike wouldn't be crossing. Okay, so please, that's how you can say can solidify over time. Where is the evidence of it solidifying? Don't have. Okay, so please don't copy blindly. When we ask you to describe using the figure, observe. What do you see? What is the nature of the lahar? All right, what do you see that is a nature? What is it like? Is it in terms of volume, in terms of consistency, or whatever? Okay, just 2 description will be worth 2 marks. All right, next, explain the impact of lahars on humans and nature near Mount Merapi. Okay, so now you see that it's specifically on the river. You don't see it burying human villages or whatsoever, right? Okay, so you could tell me how does this lahar filling up the whole river can affect humans and it can affect nature. Okay, so again, don't copy blindly. You don't see any forest here being buried. Don't go and tell me forest. You don't see villages being buried. Don't tell me villages. Apply your learning. What has this river being filled with lahar got to do with humans and nature? Okay, tell me the steps. So 2 marks for humans, 2 marks for nature. Okay, and we will discuss this in class. All right.